Good afternoon, students. My name is niallflynn, and today I'll be guiding you through this podcast, which consists of arithmetic sequences and generating the nth term. On completion of this presentation, viewers will be able to understand what an arithmetic sequence is, form the nth term of an arithmetic sequence, understand the difference between an arithmetic sequence and a series, and develop their knowledge of sequences to move on to the next stage, which is geometric sequencing. The content outlined in this podcast is suitable for students who have completed the junior cycle curriculum and are ready to develop their understanding of numbers and patterns at senior cycle. They'll also be able to explain all the key terminology in relation to sequences and series, understand and be able to interpret the formula for finding the nth term, and also ascertain the difference between a sequence and a series. As stated in the guidelines for the Leaving Cert syllabus, students should be able to appreciate that processes can generate sequences of numbers or objects, investigate patterns among these sequences and use patterns to continue the sequence, generalize and explain patterns and relationships in algebraic form, recognize whether a sequence is arithmetic, geometric, or neither, find the sum to n terms of an arithmetic series, and further develop their understanding to be able to learn about geometric sequences. So let's look at an arithmetic sequence. An arithmetic sequence is an ordered list of numbers with each term increasing by a constant. Take the sequence 6, 10, 14, 18, 22, 26, 30. They are each increasing by 4. The sequence is increasing by 4 every time, and this is called the common difference. A arithmetic series, however, looking at the example below, is 6 plus 10 plus 14 plus 18 plus 22 plus 26 plus 30. An arithmetic series is a sum of terms, like the example above, where they are added together. The formula for the nth term in an arithmetic sequence is as follows. A plus bracket n minus 1 close bracket multiplied by d, where a is the first term of the sequence, also known as term 1, and d is the common difference between the terms, for example, term 2 and term 1. N is the term you are looking for. Having been given the formula in the previous slide, let us look to prove it. Below we are given a sequence 3, 5, 7, 9, 11, 13, and 15. The first term in this sequence is called T1, or A, which is 3. The common difference is the difference between the second and third term, which is 2. This is also the difference between the rest of the terms. As you can see, they're all increasing by 2. Our formula is Tn is equal to A plus n minus 1 times d. Let us look at the sequence in detail to prove the formula. Term 1, or A, is 3. Term 2 is term 1 plus 2, which is 3 plus 2. Term 3 is 3 plus, at this stage I'm going to use multiplication to help with this proof. I'm going to call it 2 times 2. Similarly for term 4, it's the first term, which is 3 plus, again we're adding on our 2, so it'll be 3 times 2. Term 5 is going to be 3 plus 4 times 2. Term 6 is going to be 3 plus 5 times 2. And term 7 is 3 plus 6 times 2. Having looked at the sequence mathematically, we can see what is changing is the number in front of the d value. This is also 1 less than the term value. For example, in term 5, the first term a stays the same, the difference increases, but the number of differences increases by 1 less than the term value. Hence, T5 has a 4. Therefore, we can see that the sequence follows the pattern of the formula of a, the first term, n minus 1, the term number minus 1, which is multiplied by the common difference. Again, we'll practice on the next page. Working out the nth term. Let's look at the sequence below. 2, 6, 10, 14, 18, 22, 26. A is 2 as is the first term in the sequence, the common difference is t2 take t1, which is 6 minus 2, which is equal to 4. You'll notice this is the same for every term in the sequence. They are all increasing by 4. To find the n term, we fill out our formula, which is Tn is equal to a plus n minus 1 times d. A is equal to 3, d is equal to 4. So we fill out the formula Tn is equal to a plus n minus 1 times d. Tn is equal to 2 plus n minus 1 times 4. Tn is equal to 2 plus 4n minus 4. Tn is equal to 4n minus 2. We must now test to confirm this is true. We know that term 4 is equal to 14, hence we will sub in 4 for n. T4 is equal to 4 times 4, as you subbed in 4 for n, minus 2, which is equal to 16 minus 2, which is equal to 14. This is true. Therefore, the nth term can now be used to find any term in the arithmetic sequence. At this stage of the class, I would invite you to work in pairs to complete the following problems. Take the following sequences: 1, 8, 15, 22, 29. Is this sequence arithmetic? If so, find the nth term, and thus find term 1000. Similarly, 2 minus 1 minus 4 minus 7. Is this sequence arithmetic? If so, find the nth term, and thus find term 723. I will circulate the class. If you have any questions, please ask. Having completed the group work, I would like us to take a few minutes now to watch this YouTube video on arithmetic sequences and series. As we are coming near the end of class, I'd like to briefly recap the lesson. So first and foremost, an arithmetic sequence is an ordered list of numbers with each term increasing by a constant. An arithmetic series, however, is a sum of terms. The first term in a sequence is called T1, or A. The difference between each term is known as the common difference, or D. The formula for the n term is Tn is equal to a plus n minus 1 times d, where n is the term you're looking for. The Tn formula can be used to find any term in any sequence, provided it's arithmetic. Having completed this video podcast, viewers should be able to understand what an arithmetic sequence is, form the nth term of an arithmetic sequence, understand the difference between an arithmetic sequence and a series, and have developed their knowledge of sequences to move on to the next stage, which is geometric sequencing. At this stage of the class, I would like to thank you for watching and wish you all the best in your further study of sequences and series throughout the Leaving Cert curriculum. Thank you and goodbye.
That's all, folks.